किसी का माइक ऑन म्यूट कर ले बड़ी confirm recording is on. Give me a thumbs up. Okay, great. So today's topic, we last day we have done the about the ionosphere. We have last day done about the ionosphere. Today we are going to be studying about the sky wave propagation. Today we are going to be studying about sky wave propagation. Please make notes, Harsh. Sky wave propagation. So let's start. क्या है ये sky waves? Let's see how they are made and how they are developed. Firstly, we have Dharti Mata with us. Let's say this is Mother Earth and we have an antenna placed somewhere over here. In this antenna, we put up a wave, we put up an electrical current which is somewhere about 2 megahertz से थोड़ा ज़्यादा, 2 megahertz से थोड़ा ज़्यादा. So, we all know, as we have studied over here, that this is the first type of ionospheric propagation that we are going to study. Okay, this is the first type of ionospheric propagation that we are going to study. And what is the name of this propagation? It's called surface wave, nahi, sky wave. Okay, just like surface waves, it extends from 20 kilohertz to 50 megahertz. It extends from 20 kilohertz to 50 megahertz. But does that mean we use all of it? No. So मतलब अगर मेरे पास एक एंटेना है, मैंने इसमें एक वेव डाली विच इज 2 मेगाहर्ट्ज, तो इसमें से जो वेव निकलेगी, द वेव दैट इज कमिंग आउट ऑफ दिस will also propagate as surface wave and will also propagate as sky wave. Okay, let's say if I put up a frequency which is 20 megahertz. Okay, so is this wave, this electromagnetic energy, this radio wave which is coming out of the antenna will get transmitted not only as surface waves as well as sky waves both, but the surface wave will not be able to go that far. The surface wave will not be able to go that far. Why?
Attenuation.
Because of attenuation. So surface wave is not useful over here. That is why frequencies above 2 megahertz, they predominantly or dominantly travel as sky waves. Okay, good. What about the lower frequencies? Lower frequencies also, you will have a surface wave component present, you will also have a sky wave component present, but the sky wave will get absorbed by the D layer, which we will be studying in some time. It will get absorbed by the D layer, which we will be studying in some time. तो sky wave component हट जाता है. That is why we don't use the lower frequencies for sky wave propagation. We tend to use the higher frequencies. So the usable band is from 2 megahertz to 50 megahertz. So now any frequency that is below 50 megahertz, it can bend. It can bend. See, surface waves was following the curvature of the earth. The sky wave is getting bent because of the ionosphere. Any wave that is above 50 megahertz will not bend. Sakt landa. Zakir. Okay, talking about sky wave propagation. So now if I have an antenna, I'm putting up a wave from 2 megahertz, something like that. it is going to travel both as surface wave and as sky wave. And as sky wave. Have a look. I'm going to draw the ionosphere here. The ionosphere contains ions. So it's going to be a layer. So अब इसमें से वेव निकली, ठीक है, इसमें से वेव निकली. So this wave will travel along the surface of the earth, earth, and go. Okay? This will also travel like this. This will also travel like this. A wave which is traveling like this. And it is hitting the ionosphere. It is also traveling like this and hitting the ionosphere. It is also traveling like this and hitting the ionosphere, right? Everywhere it is hitting the ionosphere. Okay, 1 second. Huh? Take a quick 1 minute break. There's gonna be some cleaning gonna happen right now. ठीक है. आ जाओ सारे आ जाओ. सो रिज्यूमिंग, तो ये जो वेव है ये सिर्फ सरफेस के अराउंड नहीं जाती है, ये सिर्फ ये ऊपर भी जाएगी एंड आयोनोस्फीयर को जाके हिट करेगी. अब मैं आपको ये ऐसे विगल 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 करके नहीं दिखाऊंगा. आई विल नॉट शो इट टू यू इन अ विगली विगली वेव फॉर्म. आई विल ड्रॉ स्ट्रेट लाइंस. आई विल बी ड्रॉइंग straight lines. Okay, now I hope you understand what refraction is. Refraction is basically, let's say I have a box and a light wave is going, it's gonna bend into the medium of a denser medium, right? and when it is going out away toward a less dense medium, a rarer medium, it is going to bend away. Away from what? Away from something known as the 90 degree to the point called the normal. Away from the 90 degree to the point called the normal. Away from the 90 degree to the point called the normal. So let's say a wave goes in this direction. What is going to happen? As long as it is in the ionosphere, as long as it is in the ionosphere, it is going to do what? Ionosphere is a layer of less optical density. ठीक है, क्या होगा? It will bend away from the normal. It will bend away from the normal. Understand? No. Tell me, Shriram.
Ionosphere, it is dense or less dense?
Optical density and actual density is lesser.
Okay.
Is different. Okay. Understand it in the simplest of way. As you go up, what happens to density?
Decreases.
So you're going from a more dense medium to a less dense medium. Can we take it that way for the time being?
Okay.
But understand that this has to do with optical density. Okay. This has to do with optical density. It's going from a medium of more density to a medium of less density. Okay. Great. So see, now यहाँ से एक वेव गई, it hits the ionosphere and it goes out. It hits the ionosphere and it flies away from the normal. Okay. Now I'll make the angle keep on increasing. Okay. Let's say this is the normal. Huh? So this is a less small angle. This is a very, very small angle, right? Now I'll keep on increasing and increasing the angle. Okay, guys. Have a look. The wave will also go out in this direction. So it's gonna go out and come emergent like this. The wave is also going to go out in this direction and it's gonna come out emerging like this. After a certain angle, called the critical angle of incidence, this wave, just after that angle, what will happen? It is going to get reflected back. It is going to get reflected back. Why? Total internal refraction. Total internal refraction. Did any wave, we'll wait for Farhad to rejoin. Hello.
Yes.
Okay. Farhad? Okay, great. Have a look. Now, this wave, this wave which came back, this is the first wave which came back. Did any wave come back before him? Did any wave come back before him? No. So that is why this wave is called the, mark it down, it's called the first returning sky wave. So what will happen, any wave that is going beyond this angle, कोई भी ऐसी वेव जो इसके बियॉन्ड जा रही है तो थोड़ा ज्यादा ही एंगल क्रिएट करेगा ये, एंड वो भी आके रिफ्लेक्ट होगा, ये भी जाएगा ये भी रिफ्लेक्ट होगा, ये भी जाएगा ये भी रिफ्लेक्ट होगा, ये भी जाएगा ये भी रिफ्लेक्ट होगा. So you have a lot of coverage. You have a lot of coverage in this area. This area, do you have coverage? No. This area, do you have coverage? Yes. So this is the first wave which will give you coverage, and coverage will only start beyond a point. Okay. So this is called what? This is the point of reception of, you're going to receive something in. So this is going to be called the point of reception of first returning sky wave. Okay? First returning sky wave. These are also sky waves, but this is the first guy. So this is the guy which is closest to the transmitter. This is the guy which is closest to the transmitter. Easy? Any doubts? Okay, good. So sky wave क्या है भाई? चलो, I'll make this diagram now very simple. एक बार वापस बता देता हूँ सिंपल वर्ड्स में. एक एंगल के पहले ये सारी वेव्स बाहर चली जाएंगी. After one certain angle, all of these waves, they will undergo total internal refraction and they will come back on down to the ground. Is my video stopped? One second, just let me check. Yeah, my video stopped. Screen दिख रही है? Yeah. So keeping things very simple, the waves before the first returning sky waves, they will go away. And just at a certain angle, these waves will start coming back. It will start coming back, coming back, coming back, coming back, coming back. Okay? No doubts? And this wave is going to be called the first returning sky wave. It is going to be called the first returning sky wave. So have a look. So this is called the first returning sky wave. This antenna will also have surface waves. This will also be transmitting surface waves, right? So okay, surface waves come. Oh fuck, it got attenuated. It got completely attenuated. So any aircraft that is over here, can he receive signals? Yes. Any aircraft that is over here, can he receive signals? No. Any aircraft who is over here, can he receive signals? Sriram said no. Why?
I said yes.
Yes. So is this space dead of signals? Good. And tell me something. How much distance did this sky wave skip? Did this sky wave skip? It skipped the distance from the transmitter. From here to here, it skipped the entire ground, right? So basically, if Vandana is watching this, I'm just specifying this for her again. Okay. वंदना देख, यहाँ पर तेरे को ना यहाँ पे रिसेप्शन मिलेगा सरफेस वेव की वजह से, और इसके बियॉन्ड यू विल आल्सो गेट रिसेप्शन. व्हाई? बिकॉज ऑफ स्काई वेव. दिस इज द फर्स्ट रिटर्निंग स्काई वेव. इसके पहले तुमको कुछ नहीं मिलना है, नथिंग यू विल गेट. ओके, ओनली बियॉन्ड द फर्स्ट रिटर्निंग स्काई वेव यू विल गेट रिसेप्शन. बियॉन्ड, इसके परे. ओके, कूल. So that is why I told you, you will be getting adequate reception over here. If your aircraft is here, you will not get reception over here, and you will get reception over here. So you do not have any signals from this point to this point. Correct? Exactly. Write down the names. This distance is called skip distance. The distance which the sky wave skipped. And this distance is called the dead space, where there is absolutely no signals available. Dead space is of course smaller, right? Everyone go to my notes, page number 16. Read down, read general terms and add it to your notes. So if you just read that definition, it is a little complex definition. I'll make it very simple for you. Harsh, read the definition for me.
Page number
16.
sky waves na.
हाँ, जनरल टर्म्स पढ़ो.
A ratio waves travel up through a ionosphere distance increases towards the middle of the layer.
बट जनरल टर्म्स थोड़ा नीचे जो उसमें जनरल टर्म्स का एक टॉपिक आएगा.
General terms. Skip distance, the distance from the tx of the point where the first
Transmitting, it is the from the transmitter. Tx is
to the point where the first returning sky wave appears at the surface. Dead space from.
तो इसका मतलब क्या हुआ? इसका मतलब क्या हुआ? Read it again. It is the distance from the transmitter.
Transmitting
It is
to the
the
point
distance.
where the
This is the transmitter. This is the transmitter, right? यहाँ से लेके कहाँ तक का distance? To the point where the first returning sky wave touches the ground. So it is the distance from this place to this place. Any doubts? Okay, next.
dead space from the point where the surface waves is totally
attenuated. मतलब ये सरफेस वेव है, यहाँ तक आके एटीन्यूएट हो गई. इस पॉइंट से कहाँ तक?
to the point where the first returning sky wave appears.
यहाँ पे. इसे हम लोग कहते हैं डेड स्पेस. Why are we studying all of this? We are studying all of this because there will be questions that are going to be asked based on the increase and decrease of dead space and skip distance. Now I know it is a very complex definition. I'll make it very simple for you. Write down about skip distance and write down about dead space. ठीक है? All of these distances, these both distances, they have a common point. They have a common point. It is the distance from point of reception of first sky wave. It is the distance from the point of reception of first sky wave. Skip distance के लिए to which point? To transmitter, to point where surface wave is attenuated. ठीक है? कोई डाउट? Do you have any detectable signal in the dead space? Why is dead space called the dead space? Because there is no signal present over here. Okay, this table will it will very come in handy for you to understand from which distance to which distance. Okay, please understand it always starts from this point, and this point is a very important point. ठीक है, इतनी मोटी मोटी डेफिनेशन नहीं पढ़ सकते तो ठीक है, चलेगा। हम लोग को उसको स्मार्ट स्टडी करके चार्ट के हिसाब से भी पढ़ सकते हैं हम लोग, ठीक है। इस डिस्टेंस से इस डिस्टेंस तक, इस डिस्टेंस से इस डिस्टेंस तक, ठीक है। गुड। Now let us talk about the ionosphere. This ionosphere does not only exists in the form of one single layer, right? It exists as several layers. So have a look. You have a look. So this is the D layer. Let's say this is the D layer. Let's say this is the E layer. And let's say this is the F layer. Okay. So this is the D layer, this is the E layer, this is the F layer. So which is the strongest?
F.
Okay. So now let's talk about what do these different layers do. So from 20 megahertz, 20 kilohertz till near about, the lower part of the MF band, 20 kilohertz, 100 kilohertz, 200 kilohertz, 300 kilohertz, 400 kilohertz, all of those bands till 1000 kilohertz. D layer absorbs all of them. Remember I told you, the sky waves can be present for n number of frequencies from 20 kilohertz to 50 megahertz, but we do not use it that much. Why? What happens? I'll tell you what happens. So whenever this thing goes, D layer has a property, it absorbs from 20 kilohertz to near about 1000 kilohertz. It absorbs, like the wave goes, it does not even go in this direction, it does not even come back, it gets absorbed, it gets completely attenuated only. Okay, does not even come out. Now E layer, for those waves which are stronger, they have the audacity, they have the strength to actually go here, penetrate this layer and then come to the E layer. But E layer is like that, mother chud. Niche jao. Go down. Right? But he cannot do that to everyone. He can only do it to those waves which are weaker than him. So he can only reflect or put down those waves which are below 2 megahertz. Which are below 2 megahertz. Okay. Then he tells them, okay, that mother go down. But there are still going to be waves which are going to be, let's say if I put up a frequency which is way more powerful, 10 kilohertz, 20 kilohertz, this is going to go up. then the BAP is gonna come. AF layer fucking refracts everything. It refracts all of them. It refracts up to 50 megahertz. And this Benchut comes and tells him go down, but Benchut. Okay. What about those guys who are above 50 megahertz? They don't get refracted. They have enough energy to penetrate him. And where do these things go? These things go up even beyond the ionosphere for satellite communication. Because I told you, waves above 50 megahertz, they don't bend. They don't bend. Any doubts? Go through this. Take a quick 2 minute break. I'll be back. I'm here only. If you have any doubts, you can ask me. After this, we are going to study about how will all of these things change when I change the frequency, when I change the medium, when I change the ionization and stuff. Okay. Take a 2 minute break. I'm here. Drink water, get freshen up, move around. Videos on, everyone. So, any doubts?
एक है,
हाँ बता ना.
हमने इतना पढ़ा है कि अगर वेव हाई फ्रिक्वेंसी में होगी तो वो जल्दी से रिफ्रैक्ट या फिर डिस्टर्ब हो जाती है, राइट? लो फ्रिक्वेंसी में नहीं होती है. हेलो.
वापस बोलना. अगर वेव हाई फ्रीक्वेंसी में होती है तो
लाइक लो फ्रिक्वेंसी वेव जो रहती है वो जल्दी से डिस्टर्ब नहीं होती किसी ऑब्स्टेकल या फिर किसी चीज से, राइट?
कब पढ़ा है? कहाँ पढ़ा है?
तो ये तो हमने स्टार्टिंग में पढ़ा था ना.
किसी ने anyone agrees to what he has said? कि low frequencies will not get disturbed.
इन कंपेयर टू हाई फ्रिक्वेंसी.
नहीं, आपने तो ये बताया था कि लो फ्रीक्वेंसी में जो होता है वो ज़्यादा बेंड होता है.
study that one. It gets reflected, but it
Are
has
you
to be
talking
at least
about
half the way. That's how we study.
reflection, Akash? Buddy, that is reflection. This is refraction.
ओके, ठीक.
ठीक है. So वो क्या था कि हाँ, an object, if a wavelength is very very big, that means very low frequency. If a wavelength is very big, then the obstacle also has to be very big to reflect it. But that is reflection. This is
हाँ,
refraction.
ओके ओके, यही पूछना
Okay?
था.
ये क्या हो रहा है? टोटल इंटरनल रिफ्रैक्शन हो रहा है.
ओके.
Okay, Harsh, tell me, you unmuted. Ask a doubt.
TX क्या था एक बार फिर से बोलना.
ट्रांसमीटर. ट्रांसमीटर मतलब ट्रांसमीटर एक ऐसा एंटीना होता है जो रेडियो वेव्स बाहर फेंकता है, और रेडियो वेव्स जो रिसीव करता है उसे हम लोग रिसीविंग एंटीना कहते हैं. Okay, so let's start and let's resume. Ankit, confirm video recording is on. One second. So let's resume. So what are the factors affecting the change of dead space and the change of these distances? Okay. Firstly, it is about the strength of the ionosphere. It is about the strength of the ionosphere, and it is also about the strength of the frequency, and it is also about something to do with the critical angle. Okay. Anything which increases the critical angle, anything which increases the critical angle will increase the distances. मतलब अगर एक वेव ऐसे रिफ्लेक्ट होके वापस आ जा रही थी और क्रिटिकल एंगल बढ़ गया, मतलब अब वो यही वेव जो इधर जा रही थी वो बाहर चली जाएगी. तुमको ज्यादा एंगल पे भेजना पड़ेगा ताकि मैं उसको नीचे रिफ्लेक्ट कर सकूं. करेक्ट? करेक्ट, यस. मुझे उसको ज्यादा एंगल पे भेजना पड़ेगा ताकि मैं उसको नीचे की तरफ रिफ्लेक्ट कर सकूं. तो ऑफ कोर्स सी बात है, अगर एक वेव जो ऐसे जाके ऐसे आ जा रही थी, अब मेरे को एंगल ज़्यादा बढ़ाना पड़ जाएगा तो उसकी रेंज बढ़ जाएगी। ठीक है, कोई भी चीज़ जो क्रिटिकल एंगल को कम कर दे, कोई भी चीज़, anything which reduces the critical angle will reduce the range, because reducing the critical angle means the wave will go up and it will come back very very fast. Earlier what it was happening, it was going here, then it was coming back, now the critical angle has been reduced. Any wave which is going here, it was earlier going out but now it is coming back inside. Okay, so what changes the critical angle? Critical angle change हो रहा है, इसीलिए changes आ रही है ना. So what changes the critical angle? If you increase the ionization, the critical angle decreases because the refractive index increases. अब मैं इतना complex में जाऊंगा नहीं, ठीक है? I'll explain it to you in the simplest of ways. In the simplest of ways. Factors affecting range. We studied the same thing under surface waves, we will be studying the same thing under sky waves as well. So what are the factors affecting range? The most important factor is critical angle, right? So let us understand critical angle first. Write down the point number 1. If your ionization increases, what will happen to the critical angle? If the ionization increases, the critical angle will decrease because now the ionosphere is very very strong. It has more ions, so it can bend the radio wave more easily. So firstly, you required a very very high angle for it to come back. Now since the ionosphere is very strong, you require a smaller angle for it to come back. So critical angle happens what? Critical angle decreases. Okay, now write down. Now I made the ionosphere strong. Now I'm going to make the wave strong. If I make the wave strong, how can I make the wave strong? By increasing the frequency. If I increase the frequency, the wave goes more strong. I told you, if you increase the frequency, the lesser is the tendency for the wave to bend. जितनी मैं ज़्यादा frequency बढ़ाऊंगा उतना कम वो wave bend होने चाहेगा, उतना वो सख्त लौंडा रहेगा. ठीक है, जितनी मैं frequency बढ़ाऊंगा तो वो उतना बाहर जाना चाहेगा. So if a wave at normal frequency was going and coming back, now if I have increased the frequency and I'm throwing in the same direction, it will go back. It will require a bigger angle for it to get reflected back. Agreed? किसी को कोई भी चीज है जो इसमें डाउट है तो क्रिटिकल एंगल का क्या हो गया? बढ़ गया. कोई डाउट है तो बताओ.
भैया हम लोग तो टोटल रिफ्लेक्शन में काम कर रहे हैं ना, टोटल रिफ्लेक्शन.
हाँ,
क्रिटिकल एंगल भी कैसा है? क्रिटिकल एंगल तो वो होता है, एंगल होता है जो 90 डिग्री में होता है.
उसके बियॉन्ड,
उसका बियॉन्ड
क्रिटिकल एंगल वो होता है जब तेरा एंगल जो वेव आएगी वो 90 डिग्री पे आएगी, राइट? करेक्ट. चल अब ये बता, ये तेरा मीडियम का वो है ट्रांजिशन, ठीक है? क्रिटिकल एंगल का मतलब समझ. ये वेव है, इतने छोटे एंगल पे आ रही है और ये 90 डिग्री हो गई, ठीक है? ये वेव है, इसकी फ्रीक्वेंसी बहुत कम है, इसकी फ्रीक्वेंसी बहुत कम है, छोटे एंगल पे ही वो बेंड हो गई, ठीक है? सो अगर मान लिया 30 डिग्री एंगल है, ठीक है? सो अगर मैं इसको 31 पे रखूं तो ये वापस आ जाएगा, हाँ या ना?
हाँ.
चल ठीक है. अब मैंने क्या किया, अब मैंने बोला मैं यहीं पे नाउ यही वेव में 30 डिग्री पे भेज रहा हूँ, ठीक है? यही वेव में 30 डिग्री पे भेज रहा हूँ, लेकिन मैंने क्या कर दिया, इसकी फ्रीक्वेंसी बढ़ा दी है. पावरफुल वाली वेव, बहुत पावरफुल वाली वेव, इसकी फ्रीक्वेंसी बढ़ा दी तो ये 90 डिग्री नहीं जाएगा क्योंकि ये बेंड होना नहीं चाहेगा. इट विल नॉट टेंड टू बेंड, सो इट विल बी गोइंग आउट लाइक दिस. तो इसका क्रिटिकल एंगल क्या हो गया? तो इसको 90 डिग्री करने के लिए मेरे को ज़्यादा बढ़ाना पड़ जाएगा, कुछ यूं. तो इसका क्रिटिकल एंगल 30 था, 40 हो गया. तो नाउ दिस विल ओनली कम बैक आफ्टर 41 डिग्रीज. तो फ्रीक्वेंसी बढ़ाने से क्रिटिकल एंगल बढ़ा, करेक्ट। यही सेम चीज यहां पर भी होगा। अब मैंने फ्रीक्वेंसी बढ़ाई, ये तेरा आयोनोस्फीयर है, ठीक है, ये तेरा आयोनोस्फीयर है, ये तेरी वेव जा रही थी ऐसे, ये तेरी वेव जा रही थी, तो क्रिटिकल एंगल पे 90 होके निकल गया, ठीक है। तो चल क्रिटिकल एंगल प्लस 1 डिग्री का कंसिडर करते हैं हम लोग, तो ये वापस आ रहा है, क्रिटिकल एंगल प्लस 1 डिग्री पे वापस आ रहा है। मैंने इसकी फ्रीक्वेंसी बढ़ा दी, तो क्या ये वेव वापस आएगी? नहीं, ये वेव वापस नहीं आएगी, ये वेव निकल जाएगी। दिस वेव विल गो आउट, इट विल नॉट कम बैक। यही वेव यहाँ पर भी जा रही है, ये भी वापस नहीं आ रही, ये भी निकल जा रही है, ये भी वापस नहीं आ रही, ये भी निकल जा रही है। वापस कब आएगी? अब ये इस एंगल के बाद ही वापस आएगी। तो पहले ये ऐसा था, अब वो ऐसा हो गया, तो क्या हुआ, तेरी सारी डिस्टेंसेस बढ़ गई। अब पता चला क्रिटिकल एंगल चेंज होने से डिस्टेंस कैसे चेंज होती है, ठीक है। क्या नहीं समझा, अब बता।
समझ गया।
पक्का?
हाँ
शॉर्ट।
हाँ।
अगर ऐसा लग रहा है नहीं समझ आया और टप्पा गया तो भी बता दे, मैं वापस अच्छे से समझाऊंगा। चलो, तो क्रिटिकल एंगल बढ़ने से सारी डिस्टेंसेस बढ़ जाती हैं, क्रिटिकल एंगल कम होने से सारी डिस्टेंसेस कम हो जाती है। लेट मी एक्सप्लेन इट। सो फॉर एग्जांपल, इफ आई हैव अ चेंज इन आयोनाइजेशन, if I have a change in ionization, this is Dharti Mata, this is ionosphere. So now if the ionosphere is strong, he will hit a harder slab. If the ionosphere is weak, he will hit a smaller slab. Okay, it's that simple. Weak ionosphere goes out, weak ionosphere goes out, weak ionosphere goes out. But if the ionosphere is suddenly become very, very strong, see, if the ionosphere becomes suddenly very, very strong, all of these waves, they will not go, they will come in back. So skip distance क्या हुआ? Skip distance यहाँ तक था, skip distance क्या हो गया? कम हो गया. Did the skip distance decrease? Very good. So whenever ionization increases, critical angle decreases. If the critical angle decrease, मतलब छोटे एंगल पे वो रिफ्रैक्ट कर दे रहा है, दत नीचे जा, ठीक है। एंड skip distance will also decrease. Okay, we all saw this, how earlier the skip distance was this big, now it is only this much. For those who are seeing it in the recording, see this explanation again ताकि दिमाग में घुस जाए. What will happen to dead space? Earlier dead space was also from here to here. Now it is only from here to here. So dead space has also decreased. But it decreased from only one end or both the ends? दोनों साइड से डिक्रीज हुआ. ये देख, इधर से डिक्रीज हुआ या इधर से भी डिक्रीज हुआ? किस साइड से डिक्रीज हुआ? ये सिर्फ इस साइड से डिक्रीज हुआ. Only from one side, only from the reception end, only from the receiving end. It decreased, but only from receiving end. Okay? Any doubts? इसका टेबल बना लेना अच्छे से. Now explain me, Sriram, what will happen if the ionization decreases? Explain it to me with the help of a diagram.
So we have a transmitter,
Okay.
and when the ionization and when waves are transmitted upwards.
Okay, so the waves are transmitting upwards. So ionosphere is very, very strong right now. Okay, so it is sending all of these waves back. What will happen?
Critical angle first decreases.
Okay, so the critical angle decreases.
Yeah, because ionization decreased, right? And waves are transmitted outward.
See, it's very simple. Ionization का increase decrease means ionosphere का power. Okay, ionosphere is a guy sitting at the top level. He's telling you that mother chok. Simple. If the ionosphere is strong, he can refract the waves at a very, very small angle also. He can refract the waves at a very, very small. Refraction, total internal refraction happens at big angles. Only at big angles. But if the ionosphere is strong, he can also refract the waves at small angles. Correct? So if I am strong, I can suppress it more. I can ask him to go back down at smaller angles also. Okay, so now if my ionization has decreased, can I ask the waves at very small angles to go down? No. They will end up penetrating me. Did you get it? Not get it?
Some more clarity would be helpful.
Okay. रेडियो वेव जब भी कम एंगल पे आएगा, whenever the radio wave comes at a small angle, it will penetrate. It will go down if it is coming at a very big angle. Cool. So the power of the radio wave lies in coming at a very small angle. The power of the ionosphere lies in at coming in a very, very big angle. But if ionosphere is very, very powerful, even if the radio wave is trying to come in at a very small angle, he'll tell him, go mother chok, niche. Now do you get it? Pakka. Now tell me what will happen if the ionosphere, he was very, very strong, now he goes weak. Will he be able to suppress the small angle guys?
No.
Are you sure?
Sure.
So all of these guys which are getting refracted very, very early on, all of these guys which are getting on refracted very, very early on, will he be able to continue refracting them? क्या ये उनको और नीचे फेंकते जा पाएगा? नहीं फेंकते जा पाएगा. तो ये वाली वेव्स बाहर निकल जाएंगी एंड ये वाली वेव आएगी. जो दूर वाली वेव है, ज्यादा बड़े एंगल वाली वेव है. पहले वेव फर्स्ट रिटर्निंग स्काई वेव वाज दिस. नाउ द फर्स्ट रिटर्निंग स्काई वेव इज दिस. सो व्हाट हैपेंड टू द skip distance? The skip distance increased. The dead space increased. Okay. Any doubts? Are you sure?
The waves which are penetrating out, right? It would be the ones which you erased it actually, which
Sorry?
penetrate out.
One second. I'll just, I'll do what I know. It's gone a little bit here and there. I'll draw a good diagram and I will explain it very nicely once again. Everyone, listen. This is the transmitter. We have the ionosphere in red. We have the Dharti Mata in blue. Okay. This is the surface wave. Cool. Let's say we have a normal ionosphere. We have a normal ionosphere. This wave is going, it is going outwards, just like a normal one. Now we have this wave. This is also going out. And we have this wave beyond the critical angle. It is coming back. Cool. Ionosphere becomes very, very strong. Let's say this is the normal case. Now something happened and ionosphere became very strong. So the small angle waves, the waves which are hitting it at very small angles. Since the ionosphere is very strong, he will reflect more of waves downwards. So even these waves which are going in this direction, they will end up coming down like this, and they will not go over here. Understood? If the ionosphere is strong. What happened? The skip distance, which was earlier this much, it now became this much. The dead space, which was earlier this much, it now became this much. And it has decreased only from this end, from the receiving end. Understood? Now, let's say the ionosphere was very, very strong. Now the ionization has decreased. The ionization has decreased. So the ionosphere has become weak. The critical angle will end up,
Increasing.
the critical angle will end up increasing. So because it is weak, he cannot suppress the poor. So what will happen? He will have to let go of ये जो वेव वापस आ रही थी, ये वापस अभी नहीं आएगी. तो क्या हो गया? स्किप डिस्टेंस बढ़ गया, डेड स्पेस बढ़ गया. Make a note. See, I made you write over here. If ionization increase, the critical angle will decrease. If ionization decrease, critical angle will increase. Any doubts? Pakka? Now let us do the change in frequency. धरती माता, ionosphere mother. Let's say I have a wave at 2 megahertz. It is coming back. So all the waves which are going over here, they are also coming back. Correct? So this is the first returning sky wave. This wave is the first returning sky wave. So this became the critical angle. Correct? Now what did I do? I increased the frequency. I increased it from 22. I made it 20. Instead of 2, I made it 20. Okay. Now this wave has more energy. This wave has more energy. So it will tend to go out. This wave will not tend to come over here. It will tend to go out. So you have to, the wave will have to go to a very, very big angle for it to come back. The wave has to go to a very big angle, only then it will be able to come back. So whenever the frequency has increased, the critical angle has increased. And because of this, what will happen to the distances? Earlier the distance was this much, the distance has now increased. Agreed? Any doubts? Now 20 megahertz, this is the first returning sky wave for 20 megahertz. Now if I'm reducing the frequency, what will happen? If instead of 20 this became 2 megahertz, so this though will come back only. You are at a higher angle, you are at a higher angle, this will to come back only, but all the waves before this will also start coming back, no? So this is no longer the first returning sky wave. The first returning sky wave is this now, because now this one became 20, this became 2 megahertz. So this is the first returning sky wave. Okay, whenever the frequency increases, the range has to go up, 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 up. Okay. Make a note. write down one more line. Surface wave range decreases. Skip distance increases. Dead space increases. Whenever the frequency decreases, the critical angle decreases. The surface wave range increases. Skip distance decreases. तो आप लोग बोल रहे हो कि यार मेरे को समझ तो आ गया भैया, आई अंडरस्टूड, बट वॉट एवर यू रोट अबाउट सरफेस वेव आई डिड नॉट अंडरस्टूड, है ना? यू गाइस आर गोना टेल मी दिस. Okay, okay, this thing has gone, huh? This thing has gone. So just write it down. Whenever the frequency, the last line, just write it down. Whenever the frequency decreases, critical angle decreases, surface wave range increases. Farad, write it down. Surface wave range increases, skip distance and dead space increases. Anyone who wants me to repeat it? I'll write it down. Frequency, critical angle, surface wave range, dead space, skip distance. Whenever the frequency increases, whenever the frequency decreases, critical angle decreases. Okay. Now, you guys did not understand the surface wave range part. Correct? You did not understand surface wave range part. How does this have a role to play? This has a role to play with dead space. This has a role to play with dead space. Understand this. Let's again come to the diagram, guys. Let's say I have 2 megahertz. Remember, I told you over here the range only increases from the receiver end. Here, this is not the case. Here, it will increase and decrease from both the ends. It will increase and decrease from both the ends. Let's have a look how. Let us say I have a wave which is coming back at 2 megahertz. So this is also the surface wave component of it. And this surface wave component has some range. So what is the dead space, guys? The dead space extends from here to here. The dead space extends from here to here, correct? What will happen, Sriram, if I increase the frequency? If I increase the frequency, Sriram, this wave will end up going like this and end up coming back over here. So we can all see that the dead space has increased in this direction. Yes, but you guys also have to understand that what happens to the surface wave when frequency increases? The surface wave range decreases when frequency increases. Earlier it was this, now it became this. Because this is the same frequency, no? This is the earlier 22 kilohertz could go this much. Surface wave 20 can go only this much. So range is not on the dead space is not only increasing from this side, it is also increasing from this side. Okay, so dead space increases from both sides. This is why I made you write this. Any doubts? Yes.
I'm understanding surface wave range decreases due to attenuation, but the dead space explanation could you give it in
What is the definition of dead space?
like the area where just a second, point of reception of first sky wave to point where surface wave is attenuated. So if
Yeah.
frequency,
So this point of attenuation is moving further back. So it is, so the dead space region, if this see, this is the transmitter, okay, over here. This is the transmitter over here. And the surface wave extends from here to here. So this much is the surface wave range. And beyond is it is the dead space. Correct? So if the surface wave is range is decreasing, so the dead space is increasing. So dead space has two ends. No, it has the surface wave type end and it has the sky wave end. So it is increasing from this end as well, and it is also increasing from this end.
Yeah, okay, that's what I'm asking. The increase in frequency results in attenuation. As a result, the range decreases, right? Surface wave range. Got it. Yeah, thanks.
Understood? Anyone, any doubts? Okay. Now, then we have something known as the height of ionosphere. This is a very simple one. Huh? Height increases, all the distances on the range increases. Very simple. Let me explain you how. धरती माता, ionosphere माता, ट्रांसमीटर.
ये आपने अभी कुछ बोला क्या? एक बार आप रिपीट करोगे?
सॉरी,
एक बार आप रिपीट करोगे आपने जो भी बोला?
हाँ, कहाँ आपने लास्ट क्या सुना बताओ?
लास्ट आप श्री राम को समझा रहे थे.
अच्छा, वो श्री राम वाला पोर्शन समझ आ गया कि दोनों साइड से इंक्रीज हो रहा है, ये समझ आ गया.
हाँ,
हाँ,
let's
तो अभी जो नेक्स्ट टॉपिक है, वी आर स्टार्टिंग अबाउट द नेक्स्ट फैक्टर विच विल चेंज द डिस्टेंसेस, विच इज द हाइट ऑफ द आयोनोस्फीयर. सिंपल सी बात है, अगर आपकी हाइट बढ़ेगी आयोनोस्फीयर की तो आपका सारे डिस्टेंसेस बढ़ेंगे. इतना सिंपल है. एक्सप्लेन करता हूँ कैसे. ठीक है, हैव अ लुक. सो नाउ दिस इज योर धरती माता इन ब्लू, आयोनोस्फीयर माता इन रेड. The sky wave, I'm not changing anything. I'm not changing anything. No, I'm not even changing the ionization, the critical angle, frequency. Nothing I'm changing. Nothing I'm changing. We have just learned about ionosphere. It can go up and down with the charge that it gets, right? So if the ionosphere is gonna be here and it's gonna come back, so this is the range. What if the ionosphere goes up? The same wave gonna come here and it's gonna come here. See, skip distance gets increased, dead space gets increased. Very easy. If the ionosphere comes down, all the distances come down. है ना? That simple. It's like throwing a ball. It's like throwing a ball. Let's say you have a wall over here. If I throw a ball from here to this place and this place, this distance will be very less. But if I throw the ball from a very, very far away place, this distance is going to be too much big. It's like that. Okay? That is all for today.
मेरे को आप 2 दिन टाइम दो भैया, मेरे को थोड़ा सा टाइम लगेगा.
एक and make me speak to your parents. No classes for you until you make me speak to your parents.
ठीक है,
ठीक है?
अभी फोन करवा देना.
Any doubts?
इन तीनों में से प्रायोरिटी किसको ज्यादा होती है?
इन तीनों में से प्रायोरिटी किसको ज्यादा होती है बोले तो?
मतलब अगर मेरी फ्रीक्वेंसी हाई होगी और क्रिटिकल मतलब क्रिटिकल एंगल मेरा
अच्छा,
मतलब
तो यार इसका मैं समझाता हूँ. आई गॉट योर क्वेश्चन. तो भाई देख, फ्रीक्वेंसी के ऊपर हमारा कंट्रोल है क्या? आयोनाइजेशन के ऊपर हमारा कंट्रोल है? नहीं. हाइट के ऊपर हमारा कंट्रोल है? नहीं. तो हम लोग क्या करते हैं, हम लोगों को एक डिफाइंड रेंज चाहिए, है ना? आयोनोस्फीयर बहुत ज्यादा ऊपर हो गई. Shriram, please listen to this. He has asked a very good question. This is going to come tomorrow. Okay. So, he asked, out of this, which one is more priority? No. All of these things together play a very big role. And they together work. How do they work together? See, do we have control over frequency? Yes, we can control the frequency. This is something that I can tweak. But can I control the ionization? Can I control the strength of the ionosphere? No. Can I control the height of the layer? No. So, we need one set of range. Okay, I need, okay, yeah, the wave should go and come back within 200 nautical miles. Okay, the wave should go and come back within 200 nautical miles. And I have a frequency which is giving me so and so thing. But now, what if the ionosphere goes very, very weak? It's in night time. What will happen? The wave will not come back at 200 nautical miles. An aircraft sitting at 200 nautical miles will not be able to hear me. What the fuck? Because the skip distance has increased, right? So what should I do to decrease the skip distance? I should decrease my frequency. Okay, so ionization decreased, so my skip distance will increase automatically, right? वो दूर तक जाएगा. It will go very, very far and come back. I don't have control over ionization. I don't have control over height of layers. So what should I do? I should decrease the frequency so that I can maintain the range. In the sun, in the daytime, the frequency, the ionization becomes very strong. So the guy at, so now I'm using a smaller frequency. So now the guy at 200 nautical miles is able to hear me, but the guy at 80 nautical miles is also able to hear me. I don't want the guy at 80 nautical miles to hear me. Why? I have VHF comms only there. VHF can go there. I only want 200 and above to hear me. So I have the liberty to increase the frequency. कि ताकि 80 वाला वो जो फर्स्ट रिटर्निंग स्काई वेव मिल रहा था वो बढ़ते 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 200 तक पहुंचता है. The guy at 80 nautical miles now with the reduced frequency Shriram who was getting the first returning sky wave, I will increase the frequency so that that first returning sky wave goes to up till 200. So there is a very simple rule: sun up, frequency up; sun down, frequency down; sun down, ionization down, so frequency has to be made down so as to maintain the range. If the sun goes up, ionization increases. So all the frequencies will get reflected. So I can increase my frequency. Then Ankit has a question. Sir, why then we not use a low frequency? Everyone will be able to hear me. The answer is in the voice clarity. The answer is in the voice clarity. The higher the frequency, the better is the voice clarity. So we always tend to use a higher frequency. In your car radios, you have AM and FM. AM is in kilohertz. Have you ever heard that sound? Very, very cracky sound. But FM, super high frequency, no? FM is 93.5 megahertz. AM is what? Kilohertz. That is why you get very, very good audio in FM. Higher the frequency, better the voice resolution. Understood? So Akash, we tweak the frequency in our way so that we can compensate for the other changes. Okay, good question. That is all for today. Any doubts? Any doubts? No? Okay, let's call it a day then.